Hi everyone, so welcome again to Master 30. So for this video, sitting lectures, I will discuss the cylinders and the quadric surfaces. So let's start with a cylinder. So a cylinder is a surface that consists of all lines, which is called rulings that are parallel to the given line and pass through a given plane curve. So in order to graph this cylinder surfaces, so cylinder is not just a cylinder now, we will see this later. So to be able to graph surfaces, we need to find the intersections, no, or the planes intersections of this surfaces, which is called traces. So let's say for example, we have this function, no? So we have here a function z is equal to x squared in a space. So how do we graph that? So if this is just a z versus an x coordinate system, no. So if this is just a two-dimensional coordinate system wherein the vertical axis is z, the horizontal axis is x, it will be easy, So this is just a parabola. We can recall parabola at the origin, right? But if we want to graph this in a space or in three dimensions, then the graph of that will be translating in terms of y. So there is no y here. Therefore, y's domain, so y's domain is any real number. No? So this will be any real number, meaning from negative infinity to positive infinity is the domain of your y. So meaning, if we graph this in three dimensions, no? Okay, so this is your uh, three-dimensional space. So this is the z-axis. This is your x-axis. Actually, this one is x positive. And then this is the y-axis. Then as we can see, no, using this graph, using this graph, we can identify that in this perspective, no, so this is your parabola, right? So if you look there at this, no, at this portion, no, we look at this point, then this will be the intersection or the cross section of your graph. And you can extend this, no, for this one as well. So we have here, we have this, and so on. So as you can see, the surface here is it's hard to draw this, no, in reality. We have a drawing anyways, no? So this will be your surface, including this one. So to draw this now in a much easier way, as you can see, this will be the graph of your function in three-dimensional space. So you have this function. So this is z is equal to x squared. So this is the trace. Now basically this is the cross section of your graph to help us draw this cylindrical surface or cylinder surface. So a cylinder surface is not limited to cylinders, no, that we are familiar with. This is not, no, a tin can or in general a drum. No? So a cylinder is a much more general concept in multivariable calculus. And to be specific, this is a cylinder and this is called a this example is called a parabolic cylinder. So as long as you have a trace, no, or an intersection of your surface that is equal all throughout, it is called a cylinder. That is a definition of cylinder in multivariable calculus. Now let's try more equations and see what it looks like as a surfaces. So we have x squared is equal to y squared plus 1. So what is this? This is just in your pre-calculus or analytic geometry, it is a circle with center at origin, right? You're familiar? So this will be the graph. So let's say this is your x and y. So this is your x and y axis. So we have here, this graph is x squared. It is not perfect, no. But this will be your graph for x squared plus y squared is equal to 1. So the radius of this, so the radius r is equal to 1 since this is 1 or the square root of 1 is 1. So if we do this again in its three-dimensional space, so again, we have this x-axis, we have the y-axis, and we have the z-axis. So the trace here is this circle, no? Yung tawag natin dun sa cross-section niya. So if you do not have a z in our equation, then z's domain will be any real number. Therefore, the z will be the part of our or every value of z, we have this in our coordinate. So for the trace here, so if this is the x and the y, then this will be your trace node. What I'm saying is this is your trace. And the succeeding one also, this can traverse as well in here and then a circle in here and so on. So you can see that this is just a cylinder, ano, with or a vertical cylinder in this form, ano. And then for your second one, so we have y squared plus z squared is equal to 1. So we can imagine this again as again similar approach. So let's say this is your z axis, this is your y axis. So this is a circle as well as we know it. So this will be your graph. Therefore, if you do this in three-dimensional space, so x is lacking, so we are transversing or translating within x, no? Within the x axis. So if this is z, this is y, this is x. So we can imagine this is your graph, ano, for this one, right? But we know that this is transversing. I want to make this a little bit on the perspective. Make things better in our perspective. Yeah, I think this is better. So we have this graph, which is this, but we know that x domain is from negative infinity to positive infinity. So this is the positive, this is the x negative. So this circle will continue everywhere, no, in here. So the surface here will be a cylinder that looks like this. Okay, so we have this cylinder, vertical cylinder, and horizontal cylinder using these two equations. So that is a cylinder. Okay. I think that will be all for this video. So that is a brief one, no?